Welcome back to Mindcast, the podcast where we explore the big ideas shaping our world. I'm your host, Will, and today we're diving deep into what might be the most important reframe in modern technology. We're talking about why everything you think you know about artificial intelligence is built on a fundamental misunderstanding. And I mean fundamental. What if I told you that the very term artificial intelligence is not just wrong, but actively harmful to how we understand and work with these systems? What if the competition between humans and machines that dominates headlines is actually a completely false narrative? Today, we're exploring a revolutionary framework called alternative intelligence that changes everything. We're going to discover why AI and human intelligence aren't competitors on some linear scale, but entirely different kinds of intelligence operating on completely different principles. By the end of this episode, you'll see why AI's so-called flaws, like hallucination, are actually predictable features, why the million-fold energy gap between brains and computers tells us something profound, and how the future isn't about replacement, but about an entirely new form of cognitive symbiosis. Let's dive in. Let's start with the problem. The term artificial intelligence is a misnomer, and it's not just semantics. Words matter because they shape how we think. When we call it artificial intelligence, we're implying it's a fake or inferior copy of human intelligence. This framing forces us into a competitive mindset where we're constantly asking the wrong questions. Instead of, when will AI become as creative as humans, we should be asking, what new forms of creativity does this alternative intelligence make possible? The human versus machine narrative that dominates popular media creates this zero-sum thinking that's fundamentally misleading. It positions human intelligence as the universal gold standard, making AI's differences look like failures or limitations to overcome. But here's the thing. Those differences aren't bugs to be fixed. They're features of a genuinely different kind of intelligence. Think about it this way. We don't compare a submarine to a fish and call the submarine artificial swimming. We recognize they achieve the same goal through completely different mechanisms. The submarine isn't a flawed fish, it's an alternative approach to moving through water. That's exactly what's happening here. When we adopt an alternative intelligence framework, the whole conversation shifts from competition to collaboration, from replacement to augmentation.
So, what makes these intelligences fundamentally different? It comes down to their substrates and architectures. Modern AI systems are purely digital, operating through deterministic logic to predict the next statistically probable token in a sequence. Human cognition? It's completely different. We're massively parallel, probabilistic, analog-digital hybrid computers. A neuron's membrane potential fluctuates continuously as it integrates signals. That's analog processing. But then it fires a binary action potential, digital processing. This fusion creates a probabilistic engine exceptionally good at navigating uncertainty. The human brain doesn't execute calculations, it makes predictions and constantly updates its internal models based on evidence and experience.
Now let's talk about memory. AI's knowledge is stored as static numerical weights, billions of parameters creating a compressed statistical map of training data. This creates the impossible triangle of model editing. You can't simultaneously achieve reliability, generalization, and locality when updating AI's knowledge. Human memory, complete opposite. It's dynamic, involving active reconstruction. When you remember something, you're rebuilding that memory in the present moment. This is why AI can know every Wikipedia fact, but fails simple common sense tests. Its knowledge is correlations without the causal framework that human memory provides. And forgetting isn't a bug in human memory. It's crucial for adaptation and learning, something antithetical to AI's static knowledge. But perhaps the most dramatic difference is energy efficiency, and this number will blow your mind. The human brain performs at about 1 exaflop. That's 1 quintillion floating point operations per second while consuming only about 20 watts of power. 20 watts! That's enough to run a dim light bulb. Compare that to the Frontier supercomputer, one of the first machines to break the exaflop barrier. It requires up to 22.7 megawatts. That's more than 1,000,000 times more energy than your brain uses for the same computational throughput. This isn't just an engineering detail, it's a fundamental constraint. The brain achieves this incredible efficiency through co-location of memory and processing. Synapses and neurons are intricately interwoven, eliminating the energy-intensive process of shuttling data between separate memory and processing units. Digital systems are constantly moving data around, and that's incredibly energy expensive. This efficiency gap tells us something profound. The human model isn't a flawed computer, it's an exquisitely optimized low-power computer. The current trajectory of scaling AI models by just adding more computational power is built on an unsustainable foundation. This validates the whole premise of alternative intelligence. These aren't competing on the same playing field. They're operating under completely different physical constraints. Now, these architectural differences lead to some fascinating emergent properties that we need to reframe completely. Let's start with hallucination, probably AI's most discussed problem. But here's the thing. Hallucination isn't a bug. It's a predictable byproduct of how these systems work. Large language models are optimization engines with one goal: predict the next most likely token based on statistical patterns. Within this framework, factual accuracy is just one signal among many, and often it's weaker than linguistic structure or common phrases. When faced with incomplete information, the model doesn't gracefully admit ignorance. It makes its best statistical guess with the same fluency as a factual statement. This reveals a critical trade-off. The very mechanism that enables creative writing and novel text generation is directly linked to generating plausible falsehoods. Both creativity and hallucination stem from the model's ability to traverse its training data and generate statistically probable but not necessarily factually grounded sequences. You can't eliminate hallucinations without crippling creative capabilities. The challenge isn't building a perfectly truthful AI. It's building systems that harness generative power while providing external verification. Advanced techniques like retrieval-augmented generation don't fix the underlying nature. They guide it intelligently.
Bias reveals another fundamental difference. AI bias is a technical artifact to be engineered away. It comes from bias training data or architectural properties. But human bias? Many of our cognitive biases are actually evolutionary adaptations, heuristics that provided survival advantages. From the social brain hypothesis, our intelligence co-evolved with extreme sociality, creating selective pressure for cooperation. Biases like overconfidence may have deterred rivals in resource contests. Here's the key distinction. AI is being developed to produce objective representations where bias is deviation from truth. Human intelligence wasn't shaped to be a perfect truth-finding machine. It was shaped to be an effective action-generating machine. In survival contexts, a biased worldview that promotes successful action is superior to an unbiased one that leads to inaction. This brings us to what I think is the most fascinating concept: the shape of AI thought itself. AI intelligence is genuinely alien in its operational logic. It processes information so fundamentally differently from human cognition that direct comparison is often misleading. There's this concept called parallax cognition that suggests human and AI thought observe the world from such different perspectives that their combination creates new dimensions of understanding. AI thinks atemporally. Human thought is narrative and temporal. We build meaning through stories that unfold over time, shaped by our unique life history. AI thinks without time. It can hold contradictory ideas simultaneously without needing to resolve them into a linear story, waiting for new patterns to emerge from data. As a digital system, its thought is a calculation in high-dimensional space, not a process unfolding through embodied history. AI perceives relationships in vast hyperdimensional data spaces that are literally invisible to human perception. It uncovers topologies of meaning that human intuition can only hint at through art or metaphor. While humans develop deep expertise in specific domains, switching between distant fields creates cognitive friction.
AI can leap between biology, linguistics, logic, and emotion almost instantly, seeing across context that a single human mind cannot hold simultaneously. At its core, AI thinks in space, while humans think in time. This explains AI's power in synthesis and weakness in causal reasoning.
So what's AI's unique contribution to human knowledge? I believe it's as a synthesis engine. The volume of published information has far outstripped any individual's or team's capacity to absorb and process it. Researchers struggle to keep track of developments even within their own specialized fields, let alone identify revolutionary connections across different domains. AI-powered research assistants like Elicit, SciSpace, and Laser AI can ingest and analyze thousands of academic articles in minutes, performing tasks that would take human researchers weeks or months. They extract key data points, summarize complex papers, identify themes, and accelerate systematic reviews by up to 80%. This frees human researchers to focus on higher-level cognitive functions, interpretation, critical analysis, and creative thought. AI functions as a modern catalyst for multiple discovery, that historical phenomenon where breakthroughs emerge simultaneously from different researchers when foundational knowledge reaches a critical point. Think about calculus, developed independently by Newton and Leibniz, or evolution by Darwin and Wallace. These weren't coincidences. They occurred because accumulated knowledge had reached a point where synthesis into new, overarching theory was imminent. AI systems collapsed the time and distance that separated researchers in the past, making the entire corpus of human knowledge a single, interconnected, queryable web. This capability reveals how AI creates seemingly novel ideas through mega-interpolation across the vast manifold of recorded human knowledge. A human expert's knowledge, while deep, is confined to a small region of this space. When AI connects concepts from distant disciplines, it appears revolutionary to humans. For the AI, it was interpolation within its comprehensive internal map. This manifests in two key ways: identifying novel correlations in vast datasets, and automated hypothesis generation. Systems like Google's AI co-scientist generate research ideas for drug repurposing that have been validated in experiments. This reverses traditional scientific workflow. Instead of humans slowly formulating single hypotheses, AI generates arrays of plausible hypotheses by synthesizing entire knowledge bases. The critical human skill shifts to curation, prioritization, and rigorous experimental design to test the most promising AI-generated ideas. So, what does the future look like? We're moving toward cognitive symbiosis, the human-AI centaur. This isn't a simple user-tool relationship, but deeply integrated cognitive partnership where distinct capabilities fuse for common goals. AI's strengths are speed and scale in processing information, analyzing massive datasets, and recognizing complex patterns. Human intelligence excels where AI falters: creativity, robust causal reasoning, contextual understanding, and ethical judgment. We possess embodied experience that allows us to navigate ambiguity and make nuanced decisions. This redefines the human researcher's role toward higher-order cognitive functions: the epistemic director, setting research agendas; the critical verifier, serving as checkpoint for validity and integrity; and the knowledge weaver, synthesizing AI's outputs into coherent narratives, translating raw knowledge into applicable wisdom. The future isn't about a single AI. We're transitioning toward diversified, multimodal portfolios. The AI landscape is diverging into ecosystems of specialists: Grok with real-time social media access, Gemini integrated in Google's ecosystem, Claude optimized for safety and long-form content, DeepSeek elite in coding and mathematics. Harnessing this diversity requires sophisticated orchestration through multi-agent systems that decompose larger goals into specialized subtasks, or ensemble methods combining outputs. The strategic high ground is shifting from who has the best single model to who has the best orchestration platform. But we're navigating risks too. There's potential for cognitive offloading, where over-reliance on AI leads to decline in human critical thinking. Technology experts fear AI negatively impacting empathy and capacity for deep thought by 2035, yet express optimism about AI enhancing curiosity, problem-solving, and creativity, freeing human energy for more spiritual, emotional, and strategic aspects of life.
The deepest question looming over this coevolution is the possibility of an intelligence explosion or the singularity. This is a potential future inflection point where AI becomes more intelligent than its creators and designs even more intelligent successors, creating a feedback loop of recursive self-improvement that vastly outpaces biological evolution. This represents both enormous existential opportunity and the greatest existential risk. The central challenge, called the control problem or alignment problem, is ensuring that recursively improving superintelligence remains aligned with human values and well-being. As we wrap up, let me leave you with this. The analysis we've covered leads to a clear conclusion. AI and human intelligence aren't different in degree, they're fundamentally different in kind. They're distinct architectures born of different substrates, shaped by different forces, oriented toward different ends. The human cognitive model isn't the less capable architecture destined for obsolescence. It's an exquisitely optimized system, a marvel of energy efficiency forged by biological constraints. Its perceived flaws, the slowness, the illogic of biases, are inextricably linked to its greatest strengths: profound creativity, robust adaptability, nuanced social and emotional intelligence. The monolithic AI model is a system of immense power, with capacity for high-speed data processing, cross-domain pattern recognition, and flawless, scalable collaboration. Yet it currently lacks genuine understanding, is brittle facing true novelty, and operates with fundamentally unsustainable energy budgets.
The path forward requires reframing our mission from replacement to augmentation, designing hybrid workflows that leverage AI's unique capabilities while elevating humans to strategic direction, creative problem framing, and critical verification. We need to prioritize research in energy-efficient, neuromorphic computing to close that million-fold efficiency gap. Organizations must invest in orchestration platforms to manage diverse AI portfolios. We need to advance AI alignment and control research as models become more powerful. And we must reevaluate education for a new cognitive era, moving beyond rote memorization to emphasize critical thinking, creativity, emotional intelligence, and human collaboration skills. The future isn't about human versus machine. It's about human with machine, creating cognitive centaur systems more capable than either component alone. That's the real promise of alternative intelligence. Thanks for joining me on Mindcast today. I hope this episode has challenged you to think differently about AI and our relationship with these remarkable systems. Next week, we'll be exploring another fascinating topic that's reshaping our understanding of intelligence and consciousness. Until then, keep questioning, keep learning, and remember, the most powerful intelligence might just be the one that emerges when different forms of thinking come together. I'm Will, and this has been Mindcast.